Hey guys, I'm going to be starting a new tutorial series today. This is going to be on procedural platforming. So here's what we're going to be building today. I'm just going to show you like a little preview. And you press space and it restarts. And you can see it creates like a procedural kind of level or like terrain right now. So it'll be creating this procedural terrain. And we'll soon be able to put in the seed and stuff. And this is what we have right now. I'm going to figure out like we're going to be adding lots of more content to this. But for right now, this is what I have. I'm going to open a new Godot project. So I'm just going to go to the project list. Yes. And I actually need to save a sprite. So down in the description, you can actually download a couple of the assets. I'm probably only going to have this sprite right now because we only have the block sprite. But you can download this. I'm just going to export it real quick. Actually, I'm going to create the project first before I export it, so I can export it directly to the project. So I'm going to do new project. Click right here on Godot, make a new one. And we're going to call it Procedural Platformer Tutorial. And I also have a link down to the repository where I set up the same procedural platforming. It just won't be up to date with the newer tutorials that are going to be coming out. So just keep that in mind. Select our projects folder, create folder. And we're just going to leave it open GLES 3.0. If you want to like export it to like the web or mobile, I would recommend doing GLES 2.0. Now, that being said, this tutorial is more orientated for people that are familiar with Godot. If you're still new to it, I'm going to try to explain some things, but I might not fully explain a couple of things, but I'm going to try my best, and this is going to be more for like, yeah, if you're familiar. So we're going to hit the 2D tab, and the first thing that we're going to do is we're actually going to create our block. So custom node, we're going to do sprite, and I need to save our textures. So real quick, I'm just going to do file, export. I'm going to go into my Godot folder. Let's see. Platformer tutorial. And I'll just call this like, I don't know, block. Why not? We're probably gonna have different types of blocks, and I'm gonna go kind of more in depth with the terrain generation and future tutorials. But for right now, I'm gonna kind of keep we're gonna get a simple thing working. So I'm gonna drag the texture of the block right here, and you can see it's super small and it's gonna be blurry. So to fix that, you gotta go into import tab right here. Go to import, and you want to do preset 2D pixel. Now you can press re-import, and it re-imports it. But all your other sprites after you do this will still be blurry. So to set that as the default preset, you just have to go preset, set default as texture, and re-import. So now the default texture preset is the pixel preset. Okay, now let's fix our resolution stuff, because you can see the project is a lot bigger. So go project settings. I'm gonna scroll down to window. I'm gonna set width to like let's go 160 by 90. This is gonna be pretty small for right now. If you're using my assets, this block is only 8 by 8 pixels, so I'm probably thinking that it's gonna be a bit smaller. Now I want to set stretch mode to 2D and the aspects to keep, so that way it gets stretched correctly and that it won't get scaled incorrectly. So that's basically what that is. Okay, so now we kind of have our world looking thing, and I'm going to go back to scene, and I'm going to rename this sprite. Let's call it block, because that's what we call the sprite. And I think that's all we're going to have right now, is just the sprite. So I'm going to Control S to save, and we're just going to call block.tscn. And we're eventually going to organize stuff right now, but right now I'm just going to try to get the tutorial stuff done, and then we'll probably do that in a future tutorial. So press save, and we're going to make a world scene, because right now we're going to have a world that will have all the blocks in it, but right now we're in the block scene. So let's create a new empty scene. I'm just going to call it 2D scene, and we're going to call it world. So this is going to be our world, and we're going to be sending out signals to create a node. So this world is going to collect those signals and create the blocks under the world. So that's how that's going to basically work. I'm just going to save the scene right now as it is with Control S and save it as world.tscn. Save. And let's see. We're going to create our block generator, which is going to basically generate our world. And so I'm just going to add this as a separate scene. Press the little plus, and do a custom node. And we're just going to do a position 2D, because that's all it really needs is just a position. And we're just going to call this, I don't know, world generator. World_generator. And you can Control S and save this as this. So right now we can see we have the block scene, the world scene, and our world generator. So we can close out the world generator now, and we're gonna press this little link icon right here with the world scene, with the world node selected, and choose world generator, and press open. So now we have our world generator in our scene. And I think we're gonna have a default position for this for right now. I'm gonna set the position to 0. Let's see, 50 maybe. No, on the X. Actually, yeah, we'll just to like that will be too low. Sorry, I'm kind of figuring out where we're putting it. I think maybe we'll just go halfway in the screen. Right, in the future tutorials, we will have a player that will actually, the camera will move towards it. So it really doesn't matter where the position is right now. Well, then it won't matter, but right now we need it somewhere so we can actually see it. And so basically how the world generation process is going to work is the generator is going to move to the right of the screen. So it's just going to keep moving every single frame. But there's going to be a variable that is randomly set, and it will actually move in increments the grid size. Right now our sprite is 8 pixels by 8 pixels, so our grid size is 8. Depends on your sprite size, but you will set the grid size accordingly to that. So it will move in that grid pattern, and we'll have a variable that changes, telling it to go up or down, and that variable will just be random. So we could use noise patterns and stuff, but right now, well, like Perlin noise, but right now we're just going to keep it simple, and I think this is a really easy way of doing it, and it works just fine for this kind of thing, so we'll go with that. I'm going to create a script in the world generator. Let's create a new script, and you just leave everything the same. I'm going to set template to empty so we don't have like any code pre-existing in there, because we're just going to delete it anyways. And I'm gonna full screen this. So first of all, we need to get the block that we want to create. So I'm just gonna do exports packed scene. The reason why I'm doing export is so you could see the variable in the editors, and you can change it in the editor. So we're gonna export packed scene block. So now if I save this, I can unfull screen this, and I can select the world generator, and I can see the block right here. And I can drag in the block.tscn right here. There we go. And I can save that. So now we have the block we want to create, but now we need to make it, we're going to have to set up a few more variables. So we're going to do, it doesn't really matter doing a variable or export variable for this, but I'll just do export. Why not? Integer variable grid size. And the integer is basically just a rounded number, so it won't have a decimal. And for this, we're going to set our grid size to 8. Okay, so now we're going to have the function underscore process delta. And in this process, it happens every frame. And what we're going to do is we're going to do global.position, the position of the world generator, .x plus equals grid size. And we're not going to times it by delta, because usually you time stuff like this by delta, so it runs the same speed on all computers, but we want to create the world as fast as the computer can compute it. So For this, we're just going to have it keep adding to the grid size. And so the reason why we're going to have it move in a grid-like pattern is so the blocks will actually be created in the grid, because it will create the blocks at its position. Okay, so now we should have it moving to the right, but doesn't create any blocks yet. And we're going to be setting up a signal system to create the block. But we're going to use a global reference scope, so every, let's say we were in a different scene where the world doesn't exist. Well, if it was checking for the world, if it was checking to connect to the world scene, then it wouldn't see it and you get an error. So we're gonna be setting up a script that's called global that will have a variable called world, and we can check for that world, and we can see if it actually exists before we execute any code. So we're gonna go to your file system, right click on this folder right here, and we're gonna do new script. Now we're gonna call this script, we're gonna call it global.gd. So it'll be our global scope script, and we'll leave it at empty right now. Press create, double click your global script, and the only thing we're setting up right here is var world, and we're gonna set it to null. So if the world doesn't exist, it will equal null. But now we have a global script, but it's not what's it called? It's not a singleton. So a singleton is a node that is loaded in every single scene. And so basically we're going to be adding our global into the auto load in our project settings. So hit the little folder icon, global.gd, open, and we're going to call it global. And then press add, and it's a singleton. So that means it'll be in every single scene at the top of every single scene tree. Press close, and now let's see. Now we have our global script. We need to have a world script so the world can set it to itself. So attach the script. We're going to call it world.gd and press create. And now function underscore ready. We're going to say global, because we're referencing the singleton, dot world equals self. Now we're going to set up another function, exit tree global dot world. Dot world equals null. So basically what this does is if the world doesn't exist, or you move in a scene, or the world gets deleted, or something happens to the world that it's not there anymore, that's the exit tree statement, which means that global.world is equal to null, which means it does not exist. The ready, though, when the world is created, it sets it to itself, so everything else can access it. So now in our world generator, actually, we're going to make a function for our world. And this is going to be our signal. So I'm going to call this function instance node. And this function is going to contain, well, the signal. We haven't set up the signal yet, but it's going to contain the node that we want to create and the location. And so we'll set var node instance equals node dot instance, and then we'll add it as a child to the world node's instance, and set the location of the node instance equal to the location that we set up here. So basically this is going to be the basis of all of our creating our nodes, because we're always going to create under the world. Unless we're in this different scene, then we'll have to set up something else. But right now we're just going to be creating stuff from the world. So we're going to be calling a signal to the world, the instance and node under it. And you could go so far to tell the, you can do like parent or something, and then you just say parents.addChild instance. But I don't think we're going to go that in depth. I mean, you can, but I'm just going to leave it at the node and location. We're not going to do add a parent. But if you wanted something more complex, you can do a parent system too. So I'm going to save it, and we're going to go to our world generator. And you could go so far to create it in the global, create the instance node into the global, and then have everything access it. We'll just leave it here for now. I haven't experimented with that, doing a it in a singleton, but I'll probably do that and we'll figure that out. So right now we're going to set up our signal. Call signal instance node, the node and location. So this will be our custom signal. And then when it's created, if global.world is not equal to null, which means it does exist, because if it's not equal to null, then it has to be equal to the world. Then we're going to connect instance node, the object target global.world, and the string method just instance node. So we just manually connected it. And I'm just going to scroll back. Okay. So now every process, what you can do is you can just do emit signal instance node to global.world. Actually, no. The thing that we want to create is our block. So that's the node that we want to instance, and the location that we want in is our global position. Okay, that should be good now. So the problem with this is it's just going to endlessly create blocks. We need to have an end to it. You can set it up so it can be infinite, but you'd have to make it so it only creates the blocks that your position is currently at. And right now we're just going to kind of leave it at a set number of blocks that it can create. So we're going to do another export int var max blocks, and then you want to do export. Actually, you don't want to do export. You just do variable current block number. That's not export current block number, and we'll set it equal to 0. Okay, so now if current block number is less than max blocks, then we can keep creating them. Else, if it's not less than max blocks, then what we can do is we can just queue free it, because then we've created our maximum amount of blocks. So essentially, I did something wrong. What did I do? Misplaced. That's interesting. Oh, I forgot the parenthesis on the back right here. Okay, so essentially what this does is it will create, we have a max block number, and we'll probably set that to like 30 or something. That'll be like the world size. And then we have our current block number. And what we actually need to do right here is at the end, we just want to do current block number plus equals 1. So now we'll just keep adding to the current block number, and as long as the current block number is less than max blocks, then it will just keep adding them. If it's greater than max blocks, then it will get destroyed, and that's the end of the world. So we're essentially creating the blocks, and I'm actually going to go back to the world generator, and is this code in the world generator? Oh, we have our script attached to it right here, but we don't have it attached to it right here. So you just want to add your world generator, if you don't have it, right here into the inheritance scene. Okay, and I'm just going to set up our block stuff again, block.tscn. And our grid size is going to be 8, and our max block number, let's set like 30. And now, let's say we want to run our world scene. We're going to select the default scene as our world scene. I just pressed the play button to do that. And you can see our game's very small, but you can see that didn't work either. Let's see. Project settings. We need to go back to general, and we go world, not world, window. Go to window, we're going to set text width to 1280 by 720. And I accidentally toggled always on top on, and then I just turned it off on accident. We don't want our game to be always on top. That doesn't matter for this. I'll just press play. And I think I know what's happening right now. The signal is not getting connected because it's already under. So if I manually connect this or not, it should work. And we don't want to make a function. We just want to call it instance node. And press connect. Now it should work. Yeah, you can see there's something up there. I don't know why that was. That's interesting. So let's see. Global position.x plus equals grid size, current block number. Oh, did I not set the amount of blocks? Maybe right here. Nope, we have our max amount of blocks. Grid size is 8. So the reason why it's actually not getting connected is because it's actually already under the world, and what happens is if you try to connect it under the ready statement, global.world, the first frame of the game will equal null, and then the second frame of the game it does, and so that's when process is going. So what you can do is you can just do if is connected, and you just do the not. If it's not connected, instance node. This way you don't have to set up manually. Global.world instance node. It's not connected. I'm gonna full screen this. This is a bit better. Then we want to do. I also want to make sure if global.world is not equal to null, and if it's not connected, then what we want to do is we want to connect instance node to global.world and call the method instance node. I did not mean to do that. And that basically just eliminates a array statement. This way, we don't have to manually have it connected. It should automatically connect now. So I could just disconnect this and it'll work still. Yeah, but it's weird because I'm only seeing it in the corner right now. So I wonder how that is. Because we have our world generator actually down here. And maybe it's our world. Oh, node instance, go back to your world.gd, and you want to node instance.global position equals location. I missed that. See, now it should work. See, there we go. Now you just got a line of blocks, and there should only be like 30 blocks in the editor. So to check, I just hit remote, go under world, I just scroll down, and there's 30 blocks. 30 of these instances. And this isn't very interesting as a world generation because it's only making a straight line. So now we need to make it move up and down and kind of create these interesting patterns. So to do that, we're going to have to set up a variable. And let's see. It's going to have to be right here. So we're going to call this variable action. This is going to be like what action is the, I don't know, maybe there's a better word for that. Variable, we'll just call action right now. Goes random, range 0 through 20. And we're going to round it. So we got a whole number. So this is going to be like, if this is going to basically mean if this is going to allow this action, if it equals a certain, if it's in between two certain numbers, then it's going to execute a certain action. So if it's in between 0 and 4, then we'll have the generator move up. If it's in between 4 and 8, we'll have it move down. And if it's not in between those values, then it'll move straight. It'll just not move up or down. It'll just stay straight. So this is essentially how it's creating the terrain. It's very simple. So let's see. If action is less than, if it's less than, actually we'll do if it's greater than 0 and action is less than 4. We'll do that right now, that seems fine. Global, and you could tweak these values too later, depending on like what type of terrain you're making. If you want a really spiky terrain, then you'd make this value very much higher. You can like 0 to 8, then yeah, you'd have very spiky terrain that goes up. So there we go, we have that, and our global position .y minus equals. So that means if it's in between 0 and 4, it moves up. And we're going to do else if action is less than, if it's greater than 4 and action is less than 8, global position.y plus equals grid size. There you go. You have your randomness already into it. That easy. And there you go. You kind of have, let's keep rerunning it. And if you're unhappy with it, you can actually change these values. So you can go like 6 and 12. Actually, no, you just go 6 and 6 and then 12. And then you have more of a bumpy terrain. And I'm going to set up a thing. Let's just put it into the global right now. And let's go to our project settings again. I'm just going to go over to input map. I'm just going to minimize all of this right now. I'm just going to create an action called restart. And we're just going to assign this to the key R. So function underscore process if inputs dot is action pressed restart. Then what we want to do is we just get tree dot reload current scene. This will restart the game whenever we press the restart button. And you see we can get these kind of cool different terrains each time. And you can set a seed value and you get the same terrain using the same seed value, which will be, it's just kind of cool. But for right now, this is what we have. Let's see what else we can do. You can also set a max height and max you can set a max height and like max so it just doesn't go higher than one value and lower than one value. So you just clamp the position. So what you can do is you just do global position dot y equals clamp global position dot y. That's the value that we're clamping. The minimum height that we want, let's say 20, and our maximum, I don't know, 70. Now let's run it. It should not go higher than 20 or below 70. Ooh, that's interesting. I think that got clamped right there. That's kind of shifting though. I don't think I should do that then. Let's not do that then. You can actually check in between a variable. But for right now, I think we'll just leave it here. And it's pretty cool getting your terrain going. But this is kind of like, Terraria in its aspect of creating terrain. And if you want, we're actually going to go in our project settings. And I'm going to set our environment. If I can find it, it's always hiding. I can't find it. Environment right here. We're going to set default clear color. Let's just set the black. Right now, I'm kind of going for like a 1-bit looking game, but you can completely change it like to however you want. But for right now, it's going to be 1-bit for my art style. Remember, Google Drive link is in the comments, in the description if you want it. I'll be making a couple tutorials about this series, and we'll be adding lots of content, and it should be a lot of fun. So if you like this video, hit like, and if you didn't like this video, then I guess don't like it. Feel free to subscribe if it really helps me out, and I'll see you guys in the next one.